first modern steam engine was invented in England in the early 1700s, helping launch the Industrial Revolution. Today there's a return to steam power. Due to its different configuration and combustion process, a steam engine produces less pollution than a regular internal combustion engine. The steam engine burns fuel in an external combustion chamber. The resulting heat turns water into pressurized steam that enters the cylinders, pushing pistons, turning a crankshaft that powers the drivetrain. Because this engine doesn't burn fuel inside the cylinders like a traditional car engine, it can run on any type or mixture of fuels with fewer emissions. The circular engine block is made of aluminium. Technicians install studs to hold 6 stainless steel cylinders. Due to the constant exposure to steam, all engine parts are made of rust-proof materials. The technicians insert a piston into each cylinder. The piston is aluminium, with a heat-resistant carbon cap and a glider to isolate it from the cylinder wall. They connect the piston rods to the crankshaft in the center with a specially designed component called a spider bearing. This bearing is designed to modify the piston stroke, producing a smoother rotation of the crankshaft and more power to the engine. Unlike a traditional car engine, with cylinders arranged in line, these cylinders are in a radial configuration and therefore equidistant from the center. This prevents the engine from warping under high temperatures. They place a counterbalance over the spider bearing to further smooth the motion of the crankshaft. Now they install a push rod over each cylinder. It operates a valve which lets steam enter the cylinder and move the piston. They insert the base of each push rod into a guide ring. Then attach the cylinder heads, each of which houses a steam entry valve. They insert the push rod into the valve. Then, to complete the assembly, they install the cam, which pushes the rods as the shaft spins. The factory hooks up every completed engine for a couple of rounds of performance testing. First, a trial run using air pressure to check for leaks and to verify that all the components operate correctly. If everything's fine, then they repeat the process with steam pressure. This type of steam engine can power many types of machines, from cars, trucks and boats to electric generators, as we see here. In a vehicle, it doesn't require a transmission because it produces so much rotational power. Now for the heat exchanger, the component which turns water into engine powering steam. Technicians use a motorized wheel to wind 6 meters of stainless steel tubing into a coil. They bind the coil with steel thread, putting a stitch in between each tube to create a minute gap. That way, when fuel burns in the combustion chamber, the heat can travel over and in between the tubes, heating the water inside faster and more efficiently than if the heat would contact only the coil's top and bottom surfaces. The result? Superheated steam in just 5 seconds. They stack 6 of these coils, one to feed steam to each cylinder. This nest of tubes forms the engine's primary heat exchanger. They test it using any number of fuels, even waste fuels, such as used motor oil and used vegetable oil from restaurant fryers. Virtually anything that burns will do. The fuel combusts at low pressure, not at high pressure, as in a petrol or diesel engine. That means burning fossil fuels to make steam produces far fewer greenhouse gases, and most hydrocarbons burn off completely within the sealed combustion chamber. You never have to refill or top up the water because a condenser cools the steam back into water, which then recirculates. Water also acts as the engine lubricant, so the steam engine doesn't require motor oil. Besides fuel combustion, this modern steam engine can run on other heat sources, such as solar heat and exhaust heat from furnaces or engines, which is cool, or not, as the case may be.